Okay, so where we left off last time was here, talking about this problem where, it's a bigger problem, not overly crazy complex, but it's a bigger problem than what we're used to, where we start to have to put things together. And I was talking about this, well, when you're writing code, it's often nice to have this incremental approach where, like, you've got a big problem, and the big problem is made up of small problems. And the small problems are often easier to solve. So you want to be solving the smaller problems that you can easily solve first. With the idea, I find that even myself, but especially new programmers, when you want to start writing code, looking at a blank file is often rather intimidating. So you're like, well, where do I start? You're looking at a blank file. Start writing something down. Start trying to solve it. Once you've got something on that screen, it gets a lot easier to write the code. So just start trying to solve some problems. When we read the description yesterday, we were like, well, half of that crap is input and then output. So we can read all that input, calculate the total charge somehow, and then we're going to print out the final result. And like I said before, I'm showing you a solution. There's literally an infinite number of workable solutions. I'm showing you one. If you would have done it differently, if you look at the way I'm doing it, saying I wouldn't have done it, I would have done it, that's entirely fine. It's entirely fine. Now, there's good code and bad code, don't get me wrong, but the point is there's a lot of ways to solve these problems and write the code, so don't be thrown off if you think like I did it a different way than the way you would have. That's not necessarily bad. All right, so I created this like dummy function where, it's not really much going on there, right? Calculate total charge, it gets some number of parameters. I'll start with okay, total charge is 0, let's say. Then I need to know the total kilometers traveled. I need to calculate the average kilometers traveled per day. I will want to know, remember how there was that funny rule about, okay, how many kilometers above 100, how many kilometers above your average is above this 100 kilometer a day thing? We need something to go there. And then we had a couple of different rules, right? If it was rental code B, it's going to be $20 a day plus 30 cents for every kilometer driven, so I'll have to deal with that. And then we also have $50 a day and every 30 cents for every kilometer driven above the 100 kilometer a day average allowance that we get. So we'll have to calculate all these things, and then we've got that if they're 25, there's an additional insurance charge or something. Okay, so this is just a template. Obviously, this is not correct. It's full of incomplete code. If something, some number of parameters, obviously this is incomplete. But it gives us a framework, and maybe it can help us start to say okay, I need to calculate the total number of kilometers traveled. Well, I could do that pretty easily. Let's write a function called total kilometers that takes the odometer readings and that just returns the difference. I can test it easily, and there we go. Now I've got a function that can calculate the total kilometers. As I was saying last time, you might say, well, it feels kind of unnecessary to make this a function. And maybe you're right. Why make this a function? All it's doing is calculating the difference. I could have just put that line of code right here. Right? Total number of kilometers is going to be the difference in the odometer readings. N minus start, obviously. So why make it a function? And you're right. But it immediately abstracts what we're doing. Give me the total number of kilometers. I don't care how, just give it to me. The function itself knows how. I just asked the function to give it to me. Obviously, I know how. It's just the difference, right? But the point is it creates a layer of abstraction which might help us mentally in solving the problem. I need the total kilometers. Just go give me the total kilometers. It's in a function. That's also really easy to test, which is nice. We'd like to test things. So that's the idea. Even the simplest function has value. You look at this, you could probably deduce that, like, okay, it's calculating like a total distance, right? But also, like, total kilometers is a good function name too. It tells you a lot about what's going on. So there's a lot of value still in even the simplest functions. And do you see what I mean about, like, imagine I get, like, okay, look, print. Raise your hand if you know how the print function works under the hood. Of course you don't. You don't need to, because you could just use it and you know that it does what it does. So you could still use it. You don't need to know how it works in order to use it. Imagine I gave you this function, you didn't look at it. Well, great, I now have a function that can give me the total number of kilometers. Great. I don't care how it did it, I just need it. So I can ask this function to do it. And there's a value in that. Similarly with the average kilometers a day. Number of kilometers divided by days. Very simple. Obviously this is an average, but average kilometers per day is a pretty darn simple, or is pretty darn clear. And again, it's easy to test. And again, it creates that abstraction. I don't care how. I just have a function, I give it what it needs, and it gives me back what I want. And then I'm happy. So that's the idea. Number of kilometers above average. This was like a more sophisticated one. This function takes average number of kilometers, and I just say, well, if average number of kilometers is greater than 100, now I know I went over the average kilometers. So the question then is, how many kilometers did I go above the average? And well, that's easy. You just take the average minus 100. Pretty straightforward. Otherwise, how many kilometers did I go above? It's 0. If average number of kilometers is not greater than 100, then I never went above 100, so it's 0. Happy. Good. I did talk last time that this may have been a good candidate for a constant. You remember what I was saying? How, like, well, what if they change it to 150, right? Or 50. If it was a constant, it would be a little easier, because otherwise, imagine I changed this to 50, but then forgot to change that one, it would introduce a bug, you know? So making it a constant could be valuable. And also, I could argue that, like, 100 is a magic number. Remember that idea of magic number where there's just, like, I know there's a comment there, but there's a number 100. Someone might be like, what the hell's 100? What's the meaning of 100? What's the significance of 100? But if it was a constant that was called, like, kilometer allowance, oh, it's over the kilometer allowance, I understand. So constants help add readability and understandability to your code, which is pretty cool. Someone's phone over there is freaking out. Oh, there we go. It's ringing. It's flashing, though. So now let's go back, right? What would the function look like? Well, total charge that started at 0. Total kilometers traveled, call the function, I get total kilometers traveled. Average number of kilometers, call the function, get back the average number of kilometers. Down here, if the rental code is B, the total charge is $20 times the number of days times 30 cents total kilometers traveled. You may look at these and say, well, aren't those magic numbers too? Yeah, maybe they'd be a good candidate for constants as well. If it's not code B, it's $50 times the number of days plus 30 cents times, and now I'm just doing an inline function call to number of kilometers above average. Give it the average, and that'll just tell me how many above the average, right? If you don't like this and you're like, I don't like it, arguably I probably wouldn't have written this line of code if I wrote it. I'd look at that and be like, no, I'm gonna take that out and give it a better name. Like if I go here, where is it? I just copy and pasted everything here. I'd say, okay. And then there. I probably would have, I like it this way better. I think it's better this way. Do you see what the change is? I removed the function call from in there, which functionally it has the same effect, right? Because the function call evaluates to what it evaluates to. It'll be some number. But I'm saving it in kilometers above allowance, and now I'm just multiplying the 30 cents by the kilometers above allowance. There. And I got a bunch of tests here, and we can run it, and it's happy. So, go back to the original thing. All I have to do is call the function with its corresponding parameters, and I'm done. Now, I did this quickly because we spent a lot of yesterday or 2 days ago talking about this particular problem, right? So it's half of this was review of what we already did. And if you're looking at this being like, yeah, it makes perfect sense when you do it, but when I need to do it, how do I? You start and you practice. It's the only way to get better. You're not going to be good at this when you start because no one knows how to do anything before they know how to do it, obviously. And the only way you're going to figure it out is if you do it and you practice. That's it. It's as simple as that. Any questions about that? No one has any questions about that exercise? It makes perfect sense. Everyone's happy? Yeah. So I can't hear you. You mean like testing? Well, the tests won't check for that. Oh, wait, you mean like on the test? My advice is make your code as easy to understand as possible for the test. Because I'm reading, like the test is on paper, right? And so if you're writing code that's hard for me to understand, I'm going to be unhappy. So make me happy. Make it as clean and clear to understand as possible. Also, I warned you last time with that lecture activity about how terrible the handwriting was. It really didn't get much better with number 2. If I can't read what you wrote, you're going to get zeros on the test. So just put an effort into writing cleanly and clearly, please. Otherwise, it's not good for anybody, okay? So just, slow down. So to answer your question, will you necessarily lose marks? No, but if it's harder for me to mark because it's like you've added complexity to your code, it's harder for me to mark, right? So just make it as easy and simple as possible. And that's not just for me, that's for yourself as well. You want your code to be as explainable to yourself because when you got to go look at it a day later, you're not going to remember what you wrote. Other questions? All right, take a moment and I'll give you 2 minutes to do this and think to yourself and maybe talk amongst yourself if when going over this, did you think to yourself, I guess, I thought I would have done it another way, not that way. Just take a few moments, think and talk amongst yourselves if you would have done anything a little bit different. And here's some things. Yeah. It's too quiet for this. Oh, also mind the deadline shift for the assignment, right? It's pushed back a day. Whatever the next day is. Yeah. Okay. All right. Let's carry on. So we have talked about ifs, right? Now this topic is about loops. We talked about if, else, right? And by the way, if you've worked on the assignment, you would have seen a loop. That was by design. You didn't have to write it, but you had to make use of it. And what did the loop do? Well, the loop was kind of like an if statement, right? Where run this block of code if some condition is true. But sometimes we need to run a block of code repeatedly while some condition is true. So not just once, but a bunch of times. Before we do that, though, I want to make sure something is clear. We can do this. Let's work through this one together really quickly. A equals 5, print A. What should you see? 5. Okay, B equals 6, print A. What should you see? 5. A equals A plus B. What should you see? 11. Good. So A was reused. And now A equals 3. A equals A plus 1. Print A. What do you see? 4. Very good. As soon as I say A equals 3, the value in A is obliterated. It's gone. We are reusing the variable A. So, what is this? What is the value? Yeah, okay, in other words, yeah, great, we did that. Now, the point of this is to emphasize that reusing a variable there's nothing wrong with it, okay? There's nothing stopping us from assigning a value to some variable and then updating and changing what's stored in that variable. Now, ideally, the value that you're going to store in that variable, and let's say you update what it is, ideally, you want it to have like a coherent meaning. Okay, and you'll see what I mean for a second, in a second. And by the way, this right here, A equals A plus 1, this is a very common pattern. What does this do? You don't need to know what A is. What will this do? It's not a trick question. This is obvious. Well, yeah, but what? Can you be more specific?
It'll add 1 to whatever value A is.
Yeah, it increments A. It adds 1 to it. I don't care what A is, but after I run this line of code, it's going to be 1 bigger, right? That's all. This is such a common pattern that we have a shorthand for it. Now, you might say, is it really short? It is if you've got longer variable names. If you just have a single character variable name, it's not overly interesting. But this is a pattern. A plus equals 1 means the same thing as A equals A plus 1. Okay? By the way, if you like this, cool. If you don't, you never have to use it. You could just go back to using this and it's fine. That's going to be just fine. But some people like this type of pattern. In the above example, yeah, okay, great. Here, quick activity. Do this. I'll give you a minute to do this. Bless you. All right. Who figured out what plus equals 2 does? Don't be shy.
It just added to 5 there. Pretty sure it just made it 7.
Yeah, it added 2. It was the same as a equals a plus 2. Okay. What about times equals 2? What would that do, do you think? Yeah, just a equals a times 2. Did anyone try minus equals? No? What do you think it would do? Probably minus 2. Yeah, it's almost like there's some intuition behind it. So a equals 5, print, okay, actually a minus equals 2, print a, it's 3. Cool. What about divide equal? Does that work? Yeah, it does. So they're just shorthands. That's all. Want to see something wild? Check this one out. What do you think this is going to do? It's not a trick question. I know you haven't seen it, but you kind of have seen it before. It'll concatenate. Because you can add strings together. So this means A equals A plus world. There you go, right? Pretty neat. But like if I just did A plus world, you might be like, well, that does the same thing. Well, no, it doesn't. Because I would have to like reassign that to something like A, for example. And then it would work. But plus equals, it'll work on other types too, assuming the operators are defined for those types, which I think is pretty neat. All right, okay, now for the big thing. So far, if we needed to run the same code multiple times, we were stuck. We'd just have to like copy and paste the code if we wanted to. Like if I told you, I want you to print hello world 5 times, you would just say print hello world, copy, paste, 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 right? There, done. Now you've got it 5 times. The trouble with this is it's kind of annoying. It doesn't scale well. It's prone to errors. And it won't work for some variable number of times. Like, well, what if I say print hello world n times? And then you're left going like, well, what's n? I go like, well, I'll tell you later. You're like, well, how? I can't write that then. Yeah, you're right. Not if you are copying and pasting things. This is where a while loop would come in. Because like, okay, if I said, here's where like what I mean by it doesn't scale well. If I were to tell you print hello world 5 times, you could do it. If I said 50 times, you could do it. If I said 5 million times, you're like, I'm not doing it, right? But it turns out you could do that pretty easily with loops. So we use while statements. And a while loop is just like an if statement. It checks for a condition to be true before it runs. But unlike an if statement, once it finishes running, it goes back and reevaluates the condition. And it'll keep looping until that condition is no longer true. Let's take this code and see what happens. In fact, without even hitting run, let's clear this so it's not confusing, I bet we can figure this out together, what it's going to do. Let's use our intuition. Counter equals 0. Well, counter is less than 10. Is counter less than 10? Yeah? Print counter. Yeah, you said true. Good job. Who said true? Well done. Everyone else, you should feel bad. All right, so counter 0 is less than 10. Great. Print 0. So we see 0. And then counter plus equals 1. What does counter become now? 1. We go here. Counter's 1. Is 1 less than 10? True. Print out 1. Counter becomes 2. Is 2 less than 10? True. Print it out. Increment. Is 3? Come on.
True.
I appreciate you, but I need to appreciate everybody. Is 3 less than 10? I know you can do this.
True.
True. Print it out. Now it's 4. Is 4 less than 10?
True.
Is 5?
True.
6? 7? 8? 9, 10. Very good. So, what's printed out? 0 through 9. 10 would, yes. Well done. 0 through 9 should be printed out. It doesn't print out the 10, right? Now, why did it start at 0? Well, that's what I started the counter at. I could start it at 7, right? I could start it at negative 10, right? I can start it wherever I want. I can end it wherever I want. I can go to 11, and then it'll go to 10, right? Because 10 is less than 11. Is 11 less than 11? You could say this, and make it less than or equal to, and then it will include the 11. That's fine. But in general, this pattern right here, where the print is a stand-in for doing something. What am I doing in this loop? I'm just printing out. But I can do whatever I want in this loop. This is a very general pattern. Almost all of your while loops, well, any of your while loops that are going to run for some number of times are going to look like this. You've got a counter. You check when the counter is less than where you want to go to. You do something. You increment the counter. What's going to happen if I do this? What will be printed out if I run this code? Why? Well, 0, add 2, 2, 4, 6, 8, 10, but don't print out where the 10 is. Okay, cool. What about this? What if I do like... Look at this code. I'm going to give you 30 seconds. Look at this code. You can do this. There's no trick here. If you think I'm trying to trick you, I'm not. What does the code do? It does exactly what it says. Follow this code and come up in your head what will be printed out. Take 30 seconds, lock in an answer in your head, then I'm going to hit run and we're going to see if you're right or wrong. Okay, raise your hand if you have an answer locked in. Raise your hand if you need more time. So that means everyone else just doesn't care. All right, well. Raise your hand if you were right. Raise your hand if you were wrong. What did you think it was going to do? Just a 10, yeah? So here's why it does this. And what does the code say? Is 0 less than 10? Yeah. Add 1. It's 1. Print it out. 0 never gets printed out. And then yada, 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 we get to 9, right? Is 9 less than 10? Yes. Add 1. It's 10. Print it out. Is 10 less than 10? No. So we do get the 10 because we incremented before we printed it out. So, you know, be aware of that. Any questions about what we're seeing right here, though? I don't need to print out the counter. I can print out whatever I want. I just printed out the same thing 10 times. And yes, 10 times because we count 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? That's still 10 things. Okay? A very common pattern in computer science is whenever you have like a range of things, you would say where it starts, and where it starts is included. I would say like 0. Okay, it starts at 0. But it goes up to, but excluding the thing. So if I said 0 through 10, in computer science, often that would mean like 0 through 9. Now, obviously, I could change the syntax to make it less than or equal to, and be like, well, now it would go to 10. But in general, it's a common pattern. 0 through 10 really means 0 through 9. So the one side's inclusive, the other side's exclusive. by the way. But more on that later. Any other questions about what's going on here? All right. Yeah, okay. Yeah, there we go. Okay. Oh, yeah. So what would happen here? Okay, there we go. What happens if I do this? Take another 15 seconds and get an answer in your head. Raise your hand when you have an answer locked in. All right, so let's think about it. Counter is 0. Is 0 less than 10? Print out 0. Is 0 less than 10? Print out 0. Is 0 less than 10? Print out 0. Am I ever going to end? This loop will always run whenever this condition evaluates to true. It stops when it evaluates to false. And there is no way for this code to change where this condition evaluates to false. So when I hit run, it's just going to print out a lot of zeros. And it's going to keep going until I tell it to stop. That's it. I'm still scrolling. Let's just do this. There we go. Okay. What about this? What's this going to do? What does the code say? Counter is 0. Is true true? Yeah. Print it out. Add 1. Is true true? Yeah. Is true ever not true? False. Yeah. So when I hit run, what are we going to see? Same idea. It's going to run forever, but now it's just counting forever. Now, if you're looking at this saying like, wow, that's pretty fast, it's actually not. The reason it's so slow is because I/O printing is slow. If I told it to do this and like count to like 1 billion, it could do it like that. It's just the printing. The process of printing is what's slow for the computer, by the way. But this will just go on forever, and it just counts. It will. It's going to take a while if I do this, eh? It's going to take a while. You know what? Let's just, there we go. Okay, yeah. Awesome. What about this? It's going to do nothing. It ran. It just did nothing. Counter 0, well, false. Oh, okay, skip the loop. All right, done. It's a rather silly program, but it's a program. Any questions about what we're seeing here? Do you see what I mean? How it's an if statement, but unlike an if statement, every time it finishes, it goes back to ask the question again. All right, tracing through a function by hand. Like when I ask you, like if I were to give you this code, right, and I say to you, what does this function do, right? Now, what's interesting here is, unlike what we saw before, this has a couple of different variables here. We've got a result and we have an end. And both of these values are changing. So where before, when I was saying like, well, what's counter? You only had to think about one variable. But now we have to think about two variables. So you're going to want to keep, like, if you're tracing through a program by hand, which you should be doing, a lot of programming, a lot of good problem solving happens on paper pencil. You're going to want to like make like a table and be like, okay, well, how this is how they're changing as I go. That's so you just want to make sure you keep track of all of the variables, and don't think that like let's see. Oh. There. Okay. Look at this code and tell me what it's doing. Take a minute. Look at this code. I've named the variables too well. Let me make it harder. No. I don't know what that is. There. That'll be harder. See what I mean? How good variable names help so much? What does this code do? Imagine this was in a function and I told you to write a docstring. By the way, when writing a docstring, if you are saying things like, well, it creates a variable called b and it assigns the value 0 to it, and then it creates a variable called counter and assigns it. That's what the code, you don't have to tell me what the code, I can read what the code is telling me. I want you to tell me, like, in aggregate, what is it doing? As a functional unit, what does this do? That's the question I want to know the answer to. Can anyone tell me? Who's brave enough to tell me? What do you think?
I think that it's taking value, it's taking b and assigning its new value to be b plus counter,
Yeah.
to make it still 0, and then you're printing b and you're getting 0, and then when you come to counter, it's taking counter and adding 1 to it, and it becomes 1, and it's going to keep going, so counter will always be 1 more than b.
Not quite. That's you've got you were like half there.
Okay.
What were you gonna say?
B takes the sum of all of the counters.
Yeah. That's basically what it's doing. You were right. First time through the loop, it's 0. Then it's 1. But then you add then counter increments, and then you take 2 plus 1. It's 3. You save it. Then it's 3 plus 3, which is 6. And then it's 4 plus 6, and so on. So it's like creating a running total. It's adding up the sum of all of the numbers from 0 to like n, where n is our 0 to counter at that point in time. So if I hit run, it's going to look something like that, which is pretty neat, I think. But the point is, do you see how much more complex it got as soon as you added another variable in there? Right? Yeah. And that's fine, but how do you then make sense of it? What does the code say? Make a table, keep track of the values, you'll be able to make sense of it. That's it. When in doubt, too, add, like, print crap out, running total counter, right? And now you can actually see, okay, 0, okay, 1, okay, 2, okay, 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6, right? Like you can print it out, it's fine, right? Like if the assignment said, tell me the running total, and you did running total and counter, you're like, yeah, but you added something I don't want. Yeah, fine, just once you're happy and you understand it, get rid of it. It's fine, you don't need to keep it in there, you can get rid of it. But feel free to add as many prints anywhere you need to keep track of values as things are going on. It's a good thing. You want that. Just get rid of them when you're done. Sometimes, by the way, here's another good, very valuable use of them, right? Let's say you're writing a function and you are convinced that this loop should be running, okay? Like, I know that the counter's there, right? But let's say you're looking at this and you're like, I know that this should be running, but is it? I don't know if it really is running. I don't know. Well, you could do something just like throw a print in there and be like, did I run? Right? And like, oh, okay, yeah, okay, it did run, good. Same thing with like if statements, right? Did that if statement trigger? It should trigger, based on my understanding. Did it? Throw a print in there. If you think it's supposed to run and then it printed nothing out, something's wrong, right? It's common to see like things like this commented out in code, and it's kind of funny because it's like you can see their detective work, how they were like going through their code looking for problems. Yeah. But try not to include those things. All of my assignments are full of things like this, like if I go back to when I was in university. All right. Now here, in sum, this is an activity to do exactly what I told you to do. So whatever. Same thing. Okay. Now, all of the functions, all of the code we've written are examples of algorithms. They are algorithms. If you remember back weeks ago when we talked about algorithms, algorithms are just like a formal set of steps that you can follow to achieve something. Directions are algorithms. Recipes are algorithms. They're all algorithms. And I'm not saying that in a weird, annoying way where technically it's no, it is. It just is. But these are also algorithms, right? It's step by step what's going to happen. An algorithm, driving directions. Although algorithms can be explained in natural language like English, when programming, we write with code. And by the way, have you ever, maybe you haven't come across this yet. It's kind of a peculiar thing. Why, you know how I say like, make good code. Make it good. Make your code as self-descriptive as possible. You don't want to have to write comments to explain your code if you don't have to. You want your code to be as self-documenting as possible. English has a lot of like ambiguity in the way we speak, by design. A formal language like Python is very strict, and everything means one thing. It tries to eliminate all possible ambiguity. If there was ambiguity, we'd have a problem. So there might be a time, if it's happened to you already, great. Well, I don't know if great's, then you know. If it hasn't happened yet, it'll probably happen. Where, let's say you're writing a doc string for your function, and you're like, how the heck do I describe what this is doing? Like, it's kind of hard to explain what it's doing. And that might be because, look, your algorithm, your code, is as precise, assuming it's really good quality code, it's going to be a very nice, precise way to describe the algorithm, right? Like the code, if it's self-documenting, should be the best description of what it's doing possible. Where English is trying to explain something, but like English inherently lacks that preciseness that a formal language would have. So it's kind of like a conundrum there, which is interesting. Finding algorithms, by the way, so like assignment 1, your job is to write algorithms. The labs, you're writing algorithms. If you're a programmer, your job is to write algorithms. Finding algorithms to solve a problem is non-trivial. Some algorithms might be simple. Simple doesn't mean easy. When I say simple, I mean like, okay, we can follow these. Okay, there's nothing overly complex or crazy happening, right? But that doesn't mean this is trivial to understand, okay? Simple and easy don't mean the same thing. You can make a career out of writing and coming up with algorithms. And we'll skip this activity for the sake of time, but this is just another example of, if I were to tell you, and this is just good advice in general, especially like let's say you're working through assignment 1, and you're like, how would I write the code to do that? What's the algorithm? How would you do it? Forget the computer. If I explain to you, go count the number of Starbucks between this, this, and this, right? And I'm going to give you each location, right? How would you do it? Well, you would probably look at each one and check if it was in the box. And if it is, you count it. If it's not, you don't. That's what I would do. That's your solution. That's the algorithm. Think what you would do. You're not that special. You're a computer just like this is. You're just a different type of computer. But you are. You can follow an algorithm, follow steps, and do something. So, how do you do it? Now implement it. Again, that doesn't mean it's trivial. There's work involved, but don't forget that, well, how would you do it? Right? There's a very popular algorithm called linear search. Linear search is like one of the most famous, important things you're going to learn in 161, okay? And you already all know how to do it. If I gave you, and who's going to be a volunteer? I want someone different. Come on. Who's going to be brave? I want someone different. Who's going to be brave? I'm going to trust me. You know how to do this. I'm not going to trick you. All right, yeah. Okay, look. I give you a stack of papers, okay? So you have a stack of papers, and I say, and each piece of paper has a number on it, okay? And I say to you, tell me if there is a piece of paper in this pile that has the number 99 on it. How would you go about answering that question for me? You'd look at each paper and see if any of them had the number 99 on it. There, linear search, you're a pro. That's the step. Look at the first one. Is that 99? If it is, we're done. If it's not, are we done? No. Go to the next paper. Is this 99? No. And so on. That's a linear search. Great. Has anyone in here ever had to sort anything before in your life? Did you ever think about the steps that you followed to sort? Maybe you did, maybe you didn't. But you followed a process to sort things. You executed an algorithm. Sorting algorithms are the same, and we're going to talk about those. Algorithms are not something that you're learning about for the first time in computer science. You are all familiar with algorithms. You absolutely are. If you had to explain how to cook pasta to someone, could you do it? Of course you could. That's an algorithm. Coming up with the algorithm for certain problems is tricky. But that's the job. Okay? You understand? And remember, when you have a problem to solve, your first step is, what is the problem? You have to understand that. If you come to office hours and you're like, I'm really stuck, I don't understand the problem, obviously I'm going to try to help you, right? But you have to understand that that's part of the assignment. No, I gave you a problem, and your first step is, what the hell is he asking me to do? Don't forget that. That's part of your job. You can't write an algorithm for a problem if you don't understand the problem. Step 2, think about a solution. My advice is, never try to sit down and write code until you have some ideas. Give yourself a few days. Let ideas brew in your head while you're walking home, while you're in the shower, whatever. I don't care. Just think. And you're going to get ideas. And then you're going to sit down and you've got some ideas, try them. Put them into code. Does anyone have any questions? And just remember, you're all pro at you already are all pros at algorithms. You haven't made it this far in life without being okay with these things. You just haven't thought about them this way, maybe. Because we operate at a high level of abstraction, but you all can do it. You ever notice that strings are kind of funny? Maybe you have, maybe you haven't, right? Like, one thing about strings is like if I have the number like 55, I've got the number 55, right? Now, what's interesting about the number 55 is we write the number 55 like this, right? A 5-5. But you have to understand that, like, this is just the way I write 55. The idea of 55 is not a 5-5. You know what I mean? Like, I can count to 55, right? I could count 55 eggs, right? And be like, there's 55 eggs here. But where's the 5-5? There isn't one. It's an abstract idea, right? I just write that idea like this. So don't think that 55 is tied to this, right? I can write 55 a whole bunch of different ways. But 55 is just this concept. Where the word hello, as written, I mean, that's the word hello, though. Like, that's hello. It's the way you write it is inextricably connected to what it is, right? I know I can say the word hello, but like, that's hello. And what's funny about this is I can have a string that's this big, or I can have the string as long as your favorite textbook, because you all have a favorite textbook, I know that, right? And that would be a very long string. How can such a little string fit into a variable and such a long string fit into a variable so easily? Ooh. This is a bit of a problem that we're going to talk about, I guess, next Friday. Because there's no class on Tuesday, right? No. And then Wednesday's the test. So then we will pick up here Friday, a week today. Oh, that's so sad. All right.